Today we're going to be previewing this idea of using sinusoidal functions in order to model real-world phenomena. Now there's a lot more in depth that you can go into this than what we're going to cover in this class, but I want us to go ahead and think about the idea that the reason why we studied how to graph sine and cosine graphs and tangent graphs, but really in particular sine and cosine graphs, is that it is actually useful to have this repeating pattern. There's a lot of real life phenomena that repeats and occurs in cycles. So today I'm going to be doing an example with you about a water tide occurring in some sort of cycle. And then at home, you're going to be trying to do a similar sort of method for if it's temperature instead, because you can kind of picture temperature throughout the day also being some sort of cycle. If you ever take a physics class, a lot of things have this sort of cyclical pattern. So you're going to end up using sine and cosine modeling for that. This type of modeling is called, in general, sinusoidal, because remember that sine and cosine are really just the same function that has been shifted horizontally. So you can always model with either sine or cosine. Typically, I just personally default to sine because I think it's kind of nice to compare to 0, 0 versus comparing to 0, 1, but that's really almost more of a personal preference. You're not necessarily wrong going one way or another. In particular, with these notes, I'm going to demonstrate to you how to write the sine function for this model. But if you look at your textbook, it actually shows you how to write the cosine for this model. So it's sort of a similar idea. But let's actually dive into this. So we have the height of the tide in a small beach town is measured along a seawall. The water levels oscillate. This word oscillate is really a key thing to think that a sine or cosine function is going to help you model it between 7 feet at low tide and 15 feet at high tide. So we should already be thinking we're going to have some sort of oscillation where the lows are going to be 7 feet, the highs are going to be 15 feet. On a particular day, the low tide occurred at 6 a.m. and the high tide occurs at noon. And it also tells us approximately every 12 hours the cycle repeats, which also tells us a ton of information just even right there. Write an equation to model water levels. So in general, the way you're going to approach these problems is first you're going to commit to either doing a sine or a cosine graph. You're going to be able to find the amplitude in a similar way that we did to the past, but most likely there's also going to be some sort of vertical shift. So rather than just eyeballing it, you want to explicitly find the amplitude by doing the maximum minus the minimum divided by 2. And you want to explicitly find the vertical shift by finding the new midline, keeping in mind that for sine, usually this midline is at x equals 0. And you could, in theory, find him by averaging his max and his minimum of -1. And this concept of an average will allow you to find any sort of new vertical shift as well. You'll be doing the maximum plus the minimum divided by 2 in order to find the new vertical shift. And just to make sure you're kind of understanding, I'm going to pause. I want you to go ahead and try to find the amplitude and try to find the vertical shift yourself before I actually walk you through it. So here in particular, the maximum is 15 feet and the minimum is 7 feet. If I do 15 minus 7, that gets me 8, divided by 2 gets me 4. In order to find the new vertical shift, that would be the maximum plus the minimum divided by 2. 22 divided by 2, I was thinking about the answer there, 22 divided by 2 to get us 11. So we've already figured out this should take the form of y is equal to 4 sine something multiplied by x plus c plus 11. And we probably want to go ahead and do a quick sanity check and make sure that this is looking the way that we expect. So if we have 4 sine x plus 11, we can already see that this is shifting between a low tide at 7 and a high tide at 15. What we want to fix is when this is happening, because right now, so far, our model is saying that it has a high tide of 15 at time pi over 2 and a low tide of 7 at time 3 pi over 2, which is really just not how we measure time in general. So let's fix that. B is going to be the easiest thing to find next, because if you recall from when we studied how to graph sine and cosine, we know in order to find b that since this repeats every 12 hours, that normally it takes 2 pi to repeat, but then I can divide by that new period, which is 12 hours, to give us b. So in general, because I know it's been a minute since we've studied this, you want to do 2 pi over the period to get you b. So in particular, it looks like b here is pi over 6. So we have y equals 4 pi over 6x plus c plus 11. Now for these real world problems, rather than solving for c sort of in the methods that we did back when we were just graphing translations of sine and cosine functions, I would actually plug in a literal value to find c, especially since now we actually know how to solve sine and cosine. And you might have just noticed I made a very big error right there. I forgot to actually write down the word sine. Don't forget to do that. I guess sine is the function this occurs in. If I just had 4 parentheses pi over 6x plus c, that would actually just be a really fancy way of writing an unusual linear function. You do need the word sine, because that is the operation and that's the type of function this is. So we can pick a value to plug into this function in order to solve for what c might be. Since we know in particular, for example, that at 6 a.m. the high tide occurs, and at noon the low tide occurs. Low tide occurs at 6 a.m., high tide occurs at noon. We could go ahead and plug in some of those values. So let's plug in that we know that at 6 a.m., so I'm just going to measure time as time since midnight, so 6 corresponds to 6 hours later, times pi over 6. We know the tide is 7. So I'm going to plug in the 0.67. Where did I get the 0.67? At 6 a.m., we have a low tide, and they previously defined the low tide to be 7 feet. So I know I've got a 0.67. It would also be equally correct to plug in 12:15 instead, because they also gave us that really by saying that at noon it's 15 feet. So either of those is fine. I just already noticed that plugging in 6 is going to be pretty nice. Because I get 4 sine pi over 6 times 6 plus c plus 11 equals 7. I actually think you have enough tools in your toolbox to solve for c here. So I'm going to pause and let you try to solve for c, and then you can compare with what I get. Okay, so if we're going to keep on solving here, pi over 6 times 6, that should just get us pi. Then my goal is to get the sine function by itself. So I'm going to subtract 11 from both sides to get -4 is equal to 4 sine pi plus c. Divide by 4 on both sides, I get -1 is equal to sine pi plus c. I know that sine is equal to -1 at 3 pi over 2 equals, now I've gotten rid of the sign because I've evaluated, that's theta that gives me that, pi plus c. So I get that a possible value of c is pi over 2. You could have plugged in negative pi over 2 instead, because remember there's infinitely many coterminal angles that give me a sine of -1. Any of those would have been equally fine. But at least with the one that we solved here, we get as our final equation that y is equal to 4 sine pi over 6 x plus pi over 2 plus 11. So just to recap, the way that you're going to approach these problems is you'll know that it's looking for the actual function looking like this, because it'll have some sort of keyword like it's oscillating, it's repeating, or I'll even just say model sinusoidally. They should give you some sort of points that you'll eventually use to solve for c. Hopefully they give you at least 2 points, and in particular those 2 points hopefully are the minimum and the maximum, because that's what we really need. In order to find the amplitude, you're always going to do the maximum minus the minimum divided by 2. In order to find the vertical shift up, what you want to do is average your max and min, because that will find where the new midline of your function is. In order to find b, you should have some information about the period in your problem, so how long it takes to do a full cycle. And if you do 2 pi divided by that period, you will find your b, and then you want to plug in a point to solve for c. The plugging in a point to solve for c might feel a little bit different than what we did back in chapter 6, but that's because we didn't really have the tools to solve sine and cosine functions back in chapter 6. So this is a new way we can approach these problems. You do, of course, want to actually look at your function once you're done. So we got that this is pi over 6, and then we got this is plus pi over 12. And we should see the points that we're expecting, and we do here. We see that at 6 a.m., low tide of 7 feet, at 12 a.m., high tide of 15 feet. And if you look at your textbook, it actually gives a different model of 4 cosine pi over 6x plus 11. If you notice, that's the exact same function. The cosine didn't end up having to have any sort of shift because it already started at the peak. So if you already know it's going to start at the peak, sometimes it's kind of nice to write a cosine function instead. But writing the sine function was just fine as well. So I want you to kind of practice this process using your knowledge of how sine and cosine functions work with a very similar problem in your textbook. So it's going to be one about temperature instead. You're free to also ask me questions about this process too, but I think that it's a worthy exercise. In the order I would go in is exactly the same order I did here. I would find your amplitude, then find your midline, and that midline being what D is, and then kind of do a sanity check here that if you make this vertical shift to the middle of your graph, is it the case that if you do plus and minus the amplitude, you get plus and minus the maximum like you're expecting? Then I would find the number attached to x by doing 2 pi divided by the period. Then I would solve for what c should be. And again, this is just trying to give you some motivation on why sine and cosine functions are useful for even things beyond engineering. This is actually the fact that they repeat is actually the most useful type of application.